In this section, we're going to be discussing circles and arcs. There are going to be a lot of new vocabulary words that we're going to be going through. You can find those words on page 566 and define those words if you'd like. A lot of the words we'll be discussing throughout this note session. The first thing that we're going to talk about is arcs. Within a circle, you have an arc, which is a section of a circle. Just like a side is a side of a rectangle, is a section of the rectangle. An arc is a section of the circle. The first word we're going to discuss is semicircle, which is probably one of the words that you will recognize in this session. So with a semicircle is going to represent 180 degrees. So a semicircle is going to represent half of the circle. If I was going to label a semicircle, I would take 2 points that would be on my circle, and I would say that this is arc AB. So the arc is the actual distance from A around the circle to B. Now, if that is the case, what does line segment AB represent? If AB is a semicircle and is representing 180 degrees, that means the circle is being divided in half. So what is the term for this line segment between A and B? That term is a diameter. So from A to B is a diameter. So a semicircle divides my circle in half, and the actual connection of the points on the circle, in this case A and B, when connected, create your diameter. The next term we're going to talk about is the term major arc and minor arc. So my semicircle is representing half of my circle. My major arc is going to be an arc that is going to be greater than 180 degrees. Okay? So I want my arc to be greater than 180 degrees. So take up more than half of the circle. And then my minor arc is going to be the opposite of that, which would be less than 180 degrees. So if I was to place a couple more points on this circle, point C, point D, a minor arc will be represented by maybe arc AC here, or arc CB, or arc BD, as long as I know that the connection of the two on the circle would create an arc that is less than half of the circle. So a minor arc I could say is AC as an example, and notice this little label that I put on the top. Or maybe BD is an example also of another minor arc. A major arc is going to consist of an arc that is greater than 180. Now when labeling a major arc, especially when there's multiple points that are on here, sometimes you're going to have to go through and label it with 3 different points. Because I know that from A all the way to D, this direction is more than 180. Okay? The problem is if I say AD, I don't know whether or not I'm describing this arc from A to D or this arc from A to D. So I have to put in there what other points I hit along the way. So here, for the major arc, I would say that major arc ACD would be an appropriate answer, because I go from A, go to C, and then all the way around to D. The other way that I can name that arc is by calling it ABD instead of ACD, but I'm naming or talking about the exact same arc there. So those are those first three definitions: semicircle, minor arc, or major arc. So if they ask you to name a major arc, you know what the requirement is and what the expectations are for that. If it's a semicircle, obviously AB going this direction or AB going this direction will represent the exact same length, or you can call that the exact same measure. Okay, now what we're going to do is we're going to look at the difference between arc measure and arc length. Arc measure and arc length. The first thing we're going to look at is arc measure. And when we're talking about arc measure, the key here is to think about angle measurement. Okay? Angle measurement is the key here within arc measure. Now what we're going to be doing is creating a circle and then creating a pie chart type figure. So I'll go through here and create different sectors by creating different lines. Okay, so creating a little pie chart here, where each of these radii hit the circle. I'm going to give it a label. And I'm also going to label this middle point, the center point of the circle, as O. Now each one of these sections represents a certain amount of degrees. I know I have 360 degrees in the circle. Okay? But if I'm talking about a specific arc measurement, the arc measurement is related to the number of degrees that create the arc. For example, let's say over here that angle AOB is equal to 35 degrees. AOB creates this arc here of AB. So what I can say is that the measure, and I'm going to put an M there, the measure of arc AB is also equal to 35 degrees, because AOB is what creates that arc AB. So let's say that I know that angle AOC is equal to 90 degrees. Angle AOC is 90 degrees. Let's say that I wanted to figure out the measure of arc ADC. Well, AOC represents the angle that creates arc AC. But I want to know what the measure of arc ADC is, this major arc here. So if I already have 90 degrees being taken up between A to C, ADC is going to be the remainder of that 360 degrees, which would be 270. So with arc measure, I'm focusing solely on angle measurements. Solely on angle measurements. Now let's talk about the difference between arc measure and arc length. When we're talking about arc length, we're going to focus on circumference. So let's remind ourselves what the circumference formula is. Circumference can be found two ways: by either multiplying the diameter by pi, or circumference can be found by multiplying 2 pi r, doubling the radius, which is the same thing as the diameter, and multiplying by pi. For now, let's leave pi as 3.14. Go ahead and round that off to the nearest hundredth, the 3.14, and that's what we will use for pi in all of our problems when dealing with the circles for the next couple days. So let's say that I have a circle, one of my amazing illustrations again here. Actually not bad. Let's say I have the center point O again. Alright, and let's say that I have these two radii drawn to where this is X and this is Y. And I'll put a random point P here. Okay? The question I'm going to ask myself is twofold. Okay? The first thing I'm going to find is I want to know the length of arc XY. And the second question I'm going to ask myself is what is the length of arc XPY. Okay, so I'm finding the arc of XY and the length of arc XPY. Alright, now in terms of information, XOY here, let's say, is 120 degrees. And let's also say that each radius length, like from O to Y, we'll say is 5 centimeters in length. So now let's go through and figure out what the lengths of these arcs are. In both instances here, I first want to find my circumference. So I know that I have 5 as my radius, so I'm going to do 2 times 3.14 times my radius of 5 centimeters. And I'll do the same exact process on problem B. When I multiply that all out, I find that my circumference is 2 times 5, which is 10. 10 times 33.14 is 31.4 centimeters. So I'm dealing with the same circumference in both places. Now the calculation of the length. Since this angle measurement is 120 degrees, that is 120 degrees out of 360. If I reduce that fraction, that is 1/3. So what I'm trying to find is 1/3 of my circumference, because that's what xy takes up, is 1/3 of the length of my entire circle. So that gets multiplied by 31.4. On the other hand, if xy takes up 1/3, what is the fraction that takes up the fraction of the circle that's taken up by xpy? 2/3, right? So I'd go through and multiply that 2/3 by 31.4 to find the other arc length. So I can say 31.4 times 1/3, or divided by 3. Either way is appropriate. And that gives me 10.47. So the length of xy here is 10.47 centimeters. And then on the other side, I will do 2/3 multiplied by 31.4. And that gives me 20.93 centimeters. And you can check your answer. Now, since we're rounding, it's going to be a little different, but the combination of both of these values should equal your full circumference. That 20.93 and the 10.47 should add together to equal your circumference in this instance. So all the questions that you're going to be dealing with are focused on that concept. You're going to be asked for arc measure, which will be focusing on angle measurement, and then arc length, which will actually be focusing on length. The last thing that we're going to look at is how we can apply this to pie charts. And this mainly focuses on arc measure more so